Hello everyone. So in this video tutorial we're basically going to be talking about percentage strengths, and it's another way that you tend to express the concentration of various components in a mixture. Typically you may be required to compound a preparation, and oftentimes the active ingredient or the concentration of the active ingredient is expressed in percentage strength. So it's really important at the get-go to have a strong understanding of what it actually means, the various ways that percentage strength can be expressed, and how you go about using that information to do your calculations. So like I mentioned, this video tutorial will just reinforce those key concepts, and then we go ahead and look at about 4 strategically selected examples on how you go about applying this kind of information. So the first thing we look at is percentage weight in volume. And the key thing to understand is when we talk about percentage weight in volume, we're basically interested or expressing our information in terms of the number of grams of a constituent element in 100 milliliters of solution or liquid preparation. So it's kind of like you have a solid in there, a solid component, and the key thing is to know what its weight in grams is. It's important that you understand its weight in grams in 100 ml or 100 milliliter of solution or liquid preparation. And oftentimes it's expressed as percentage weight by volume. So the question then arises, how do you know if this W/V or W divided by V is not giving you? How do you know that indeed it is weight in volume? And like I mentioned, if you have a solid in a liquid, it alludes to the fact that it's weight in volume. So if you had a solid component like ibuprofen in a solution, or you have a suspension, that typically is going to be a weight in volume. The next thing that we do have in terms of percentage strength is percentage volume in volume. So here you are having a ratio of 2 constituents, both of which are liquids. And so the key thing here from the definition is to know that it's a ratio of the quantity or the amount of milliliters of your constituent, or the volume of your constituent expressed in milliliters in 100 ml of solution or liquid preparation. So the key difference between percentage weight in volume and percentage volume in volume is that for your weight in volume, the constituent is recorded in grams, or the amount of constituent you need is in grams, whilst in percentage volume in volume, the quantity of your constituent is in milliliters. Both of them are in 100 ml of solution or liquid preparation. There's a third one, percentage weight in weight. So kind of like if you have a paste or you have an ointment, typically you have a situation where you can express the concentration of your active ingredient in weight in weight. And what that typically refers to is the amount of your constituent in grams, very important. And this time it's in 100 grams of solution or preparation. Right. So what does this all mean? It's important that we put things in perspective. Okay. So you have your percentage, volume by volume, weight by volume, and weight by weight. Now another key relationship is your concentration, which is your percentage strength, either percentage volume, percentage weight in weight, or percentage weight in volume, is equal to the ratio of the quantity of your solute. So if you had the percentage weight in volume, your quantity of solute to be some amount in grams to the constant or to the quantity of your total preparation. So the quantity of your solute divided by the quantity of your total preparation should give you your concentration, which is some amount in grams divided by 100 milliliters or 100 grams. So let's see how that works using an example to illustrate these key concepts. In this first example, we have a situation where we have a percentage weight and volume. And what the question requires us to do is to determine, so it tells us you have a formula of antifungal shampoo. It contains 2% weight by volume of ketoconazole, right? So this is your concentration right there. And actually, you are required to determine the quantity in grams of ketoconazole that will be needed to prepare 25 liters. So let's try and isolate or have the key information that we need to solve this particular question. The first thing is the concentration, which is given us is 2% weight and volume. And what that means is you have 2 grams in 100 milliliters. The second thing is the quantity of your preparation, and that is 25 liters. So we can convert this to milliliters with the understanding that a liter is equal to 1,000 milliliters. So once you do the computation, you have 25,000 milliliters. We can now go ahead and use that important equation that we talked about. Concentration equals quantity of solute over quantity of preparation, and we can plug in the information. So we put in our concentration information, 2 grams in 100 ml on the left, and that should be equal to the quantity of solute divided by the total preparation, or the quantity of our total preparation, which is 25,000 milliliters. When you do the math, multiply both sides by 25,000 milliliters, it cancels out on the right, and then you have your quantity of solute being 500 grams. So it's quite it's really easy once you understand the definitions that we talked about, and basically you can utilize that to solve your problems. Another example on the weight by volume. It says how many milliliters of a 0.9% solution of sodium chloride can be prepared from 50 tablets, and each of these tablets contain 2.25 grams of sodium chloride. Okay, so here again, let's try and put down the key information that is given us. Our concentration is given, it's 0.9% weight by volume. What this means is you have 0.9 grams in 100 milliliters. So the next thing we need to determine, which has been given to us in kind of like parts, is the quantity of solute, right? And it tells us you have 50 tablets and each tablet is 2.25 grams. So you need to determine the total quantity, which is going to be 2.25 grams times 50, and that gives a total of 112.25 grams, or 112.5 grams actually. So we go back to our equation, which says your concentration is equal to the ratio of your quantity of solute to your quantity of preparation. We have our concentration, we have our quantity of solute. So basically we simply plug in these numbers into this equation and solve for our quantity of preparation. What that means is we have 0.9 grams divided by 100 milliliters on the left hand side of the equal to sign, and that should be, and on the right we have 100 or 112.5 grams divided by our unknown, which is our quantity of preparation represented by x. When we solve for this, we have x equals to 12,500 milliliters. So basically, if you dissolve 112.5 grams in 12,500 milliliters, you would have a 0.9% sodium chloride solution, which by the way is isotonic. So we looked at two examples of the weight by volume. Let's look at an example of the percentage volume by volume and how it works. So this question states that what is the percentage strength, volume by volume, if you have 225 grams of a liquid having a specific gravity of 0.8, which is added to enough water to make 1.5 liters of solution, right? So we know from our definition that is the percentage strength is going to be the amount of your constituent in milliliters divided by 100 milliliters. So we need to be able to, from this question, determine what the volume of our constituent is going to be. And then we know what the volume of our preparation is also going to be eventually, right? So let's look at it. The quantity of preparation is given as 1.5 liters, and in milliliters, because 1 liter is 1,000 milliliters, we have 1,500 milliliters. So we know what the quantity of our preparation is. How about determining the quantity of our solute, or which also needs to be in milliliters? And to do that, we need to connect the specific gravity information to our understanding of density to determine what that volume is going to be. So this is one of the situations where you need to make use of all the information we've talked about since the beginning of class and make that connection, right? You're connecting the specific gravity to the density, and that gives you volume. So let's see how that works really nicely in this question. So we know specific gravity is given as density of the substance divided by density of water. Our specific gravity is 0.8 in this particular case. And then we know that the density of water is 1 gram per milliliter. So we can determine what the density of the substance is. And because the density of water is 1 gram per milliliter, often than not, the density of your substance will be the numeric value of your specific gravity, but this time having units of grams per milliliter. So when we do the math, we end up having 0.8 grams per milliliter as the density of our liquid constituent. So from there, we can connect the density information that we just obtained to the volume using the density relationship, where your density of a substance is the mass divided by volume. Okay, so we have 0.8 grams per milliliter, which we just calculated, and that should be equal to the mass which was given, 225 grams, divided by a certain specified volume, which at this point in time is unknown and represented as x. So you solve for your x and you end up having 281.25 milliliters. So it's going to be this volume in our total quantity of preparation, which was given, and then we will be able to determine what the percentage strength is. So this is how it goes. The quantity of solute is now 281.25 milliliters. We go back to our very nice equation where your concentration is equal to the quantity of solute, which we just determined, divided by the quantity of preparation which was given us in the question. And then we substitute in the information as follows. So on the right hand side of the equal to sign, we have 281.25 milliliters divided by 1500 milliliters, which is the total quantity of preparation given in the question, and that should be equal to some quantity divided by 100 milliliters. Once we solve for the unknown, that gives us the percentage strength in volume by volume. Okay, so we end up having x equals 18.75% volume by volume. So as you can tell, this is real fun to do. It's really interesting. It's real simple, and the only thing is to be able to process the question the right way and make all the important connections so that you can end up using that equation, concentration equals quantity of solute divided by quantity of preparation, in one fashion or the other to solve for your unknown at any point in time. So let's look at an example of a percentage weight by weight. It says how many grams of hydrocortisone should be used in preparing 120 suppositories. And now each of these suppositories weighs 2 grams and the percentage strength is given as 1% hydrocortisone. So how do you process this question in a way that you can delineate all the key information required for your computation? Right. First of all, we have percentage. We have our concentration, which is given us as 1%, and it should actually be weight by weight. So that's weight by weight instead of weight by volume. So you have 1 gram in 100 grams. Okay, it's actually 1% weight by weight. Please pay attention to that. And the quantity of our preparation is 2 grams for each suppository. And because we have 120 of those suppositories, we need to multiply the 2 grams by 120, and that gives us 240 grams. So we simply go ahead and utilize our equation where concentration is equal to the quantity of solute divided by quantity of preparation. And so we have 1 gram over 100 grams on the left hand side of the equal to sign, and that should be equal to some unknown amount or the quantity of our solute represented by x divided by the quantity of preparation, which is 240 grams. So we go ahead, we solve for x, we can multiply both sides by 240 grams. The 240 grams cancel out on the right hand side, and you end up having x equals 2.4 grams. Right, so it's quite straightforward once you process the question correctly.